Okay, continuing with our previous session. In the previous session, we looked at how to solve using the um, method of changing the dependent variable, right? Or in other words, reducing it to normal form. Now, what we are going to do is in this session is solve one or two problems based on that principle. So let's say our first problem is x square d square y by dx square minus 2x 1 plus x dy by dx plus 2 times 1 plus x y is equal to x cube. And there there are a few things given. One is that x is greater than 0, and second is y is equal to half and y prime is equal to 1 when, or let me put it in another way, y of 1 is equal to half and y prime of 1 is equal to 1. So this is given. Okay, now because x is greater than 0, that means we can divide the entire equation by x square. So d2y by dx square minus 2x 1 plus x by x square. So one of the x's cancel out, dy by dx plus 2 times 1 plus x by x square. Y is equal to x cube by x square is x. So now here in this, p is equal to minus 2 times 1 plus x by x. Q is 2 times 1 plus x by x square, and r is equal to x. Now remember, our objective now is what? To get rid of dy by dx. Yes. For this, what we are going to do is use u is equal to e to the power of minus half integral of p dx. Now, e to the power of minus half integral of p is what? Minus 2 times 1 plus x by x dx. Okay. Now let's if we bring 2 out, what will happen is 2 and 2 cancels out, and minus into minus is plus. So nothing is left outside, and we have 1 by x plus 1 dx. Now let's integrate it. When we integrate it, we get log of x plus x. Now based on rules of exponent, we can write it as e log x times e of x. Now here e and log cancel out, so we are left with x e to the power of x. That is u, right? Now putting y is equal to uv in the equation, it reduces to d square v by dx square plus iv is equal to s. Now here iv is equal to q minus, let's take care of v later, but I is equal to 1 by 4 p square minus 1 by 2 dp by dx, which is equal to 2 times 1 plus x by x square. Q is x square, okay, minus 1 by 4 times p square. So p is minus 2 1 plus x by x, okay, and square. So this whole thing will be square minus half of dp by dx. So dp by dx would be d by dx of minus 2 1 plus x by x, right? Now here this we can write it as 2 by x square plus 2x by x square minus, here because of the square this will become 4 and this minus will disappear. So we'll be left with minus 4 by 4, which means 4 cancels out, and we are left with 1 plus x square by x square, then minus 1 by 2, and now we have to differentiate this. So minus 2 can come out, so which means minus 2 minus 2. Okay, to differentiate this, what we'll do is, let's do it in 2 steps just to keep it, to maintain some clarity. 2 by x minus 2x. No, x by x 1 it will become, so minus 2. So this would be 2 by x square plus 2x by x square minus 1 plus x square by x square minus, now here this will become 0 when we differentiate it. This will become 2 by x square, and here 1 by 2 is there. So minus 1 by 2 times 2 by x square. 2 and 2 cancels out. So denominator everything is x square. So let's add up all of them. So 2 plus 2x minus, let's open up this. So 1 minus 2x minus x square, and then we have minus 1. Okay, 2 minus 1 is minus 2. So 2 minus 2 is 0. So these three cancel out. 2x minus 2x cancel out. We are left with minus x square. So minus 1. So I is equal to minus 1. So that is one part. The other part is, if you see here, we have s, and we know s is equal to r by u. R is what in our equation? R is x by u. U is what? X e to the power of x. This can be written as x cancel out. E to the power of x can be brought up, so it becomes e to the power of minus x. So that is s. So our equation becomes d2v by dx square, right? So d2v, so that can be written as d square minus iv. So that can be written as minus 1v, or minus, actually this will be d square v minus v is equal to e to the power of minus x. This can be written as d square minus 1 times v is equal to e to the power of minus x. Now this is something that we can solve. Remember, so to solve this, what do? We come out with the auxiliary equation, that is m square minus 1 equal to 0, which means m square is equal to 1, which implies m is equal to plus or minus 1. So that means our complementary function is c1 e to the power of x plus c2 e to the power of minus x. Now we have to figure out the particular integral. Now this would be d square minus 1 e to the power of minus x. Now this we can change it to 1 by 1 minus d square. So that means minus comes out, e to the power of minus x, and this can be written as x e to the power of minus x by minus 2, which is equal to minus x by 2 e to the power of minus x. Of course, if you're not familiar with this, you have to go back to the relevant session. Okay. So our complete solution would be what? P is equal to Cf plus Pi, which is C1 e to the power of x plus C2 e to the power of minus x minus x by 2 e to the power of minus x. And the general solution would be, remember, that is y is equal to uv. U is what? X e to the power of x times v is c1 e to the power of x plus c2 e to the power of minus x by 2 e to the power of minus x. Okay. Now, remember, some additional information has been given. That means we have to figure out c1 and c2 as well. So now the additional information that is given is y of 1 is equal to half, right? And uh, y prime of 1 is equal to 1. Yes. Okay, let's take it one by one. So y of 1 is equal to e to the power of 1 c1 e plus c2 e to the power of minus 1 minus 1 by 2 e to the power of minus 1, and this is equal to half. So which implies c1 e square plus c2 e times e minus 1 is 1 minus half e times e minus 1 is 1 is equal to half. So which implies c1 e square plus c2 is equal to half plus half is 1. So this is one equation. Now the second one is y prime of 1 is equal to. So before we can figure out y prime of 1, let's figure out y prime. Y prime is um, y is, let's write that down, y is x e to the power of 2x c1 plus x c2 minus x square by 2. Okay, so let's see this. If we multiply this, we get c1 x e to the power of 2x plus c2 x e to the power of minus x. Here e to the power of x, e to the power of minus x will cancel out. So you'll be left with c2x minus, here again e to the power of x, e to the power of minus x will cancel out, or rather it will become 1, and we'll be left with minus x square by 2. Okay, so now let's figure out dy by dx. Let's take it one by one. This would be, again we'll have to apply the product rule. So c1 is common, x differential would be 1, so e to the power of 2x plus x as it is e to the power of 2x times 2 plus c2 minus 2x by, so this would be c1 e to the power of 2x plus c1x e to the power of 2x, and 2 is also there, plus c2 minus 2 and 2 cancels out, minus x. So here c1 we have, so c1 we take it as common, e to the power of 2x is also common, so this would be 1 plus 2x plus c2 minus x. Let's look at y prime of 1. Y prime of 1 would be what? In this we substitute x with 1. So c1 e square 1 plus 2 plus c2 minus 1 is equal to 1. This is the given part. So this becomes 3c1 e square plus c2 is equal to, yes, okay. So now we, what have we ended up with? We have ended up with simultaneous linear equations in c1 and c2. So this is one equation. The previous equation is what? That is this one, c1 e square plus c2, c1 e square plus c2 is equal to 1. Now c2 is same, so minus minus minus, c2 cancels out, and we are left with 2, c1 e square is equal to 1. So c1 is equal to 1 by 2 e square. So we have got c1. We have to substitute this in any one of these equations to get the other C2. So let's take C1 E square plus C2 equal to 1. C1 is 2, no, not 2, 1 by 2 E square plus C2 equal to 1. E square cancels out, and we have 1 by 2 plus C2 equal to 1, which implies C2 is equal to 1 minus half, which is half. So therefore y is equal to xex times c1ex plus c2 e to the power of minus x by 2 power of minus x. This is the solution we had arrived at. Now we are going to substitute the values of c1 and c2. X e to the power of x, c1 is 1 by 2e square. So 1 by 2e square e to the power of x plus c2 is half. So half e to the power of minus x minus x by 2 e to the power of minus x. Now, a little bit of simplification here. Let's take e to the power of x in. So what happens? First of all, okay, so x times e to the power of x goes in. So e to the power of x, e to the power of x is e to the power of 2x, and this e square in the denominator comes up, becomes minus 2, right? And this is 1 by 2 plus 1 by 2 e to the power of minus x times x. So this is 1 by 2 minus, again, e to the power of x, e to the power of minus x would be 1. So x by, so which means we can take 2 out, x by 2 times e to the power of 2x minus 2 plus 1 minus x, which means this 2 can be taken to the other side if we want, or we can leave it. So that is the solution. Process is lengthy, it seems, but the simultaneous linear equations is high school algebra, right? And then this we have already seen. I'm sure we have had enough practice on this auxiliary equation and complementary function and particular integral, right? This, all this we have already seen. So main thing here is to figure out this u to get rid of the dy by dx. And you have to remember this I is equal to this and s is equal to r by, so that is changing the dependent variable. Okay, let's do one more problem. Now that we have worked on one problem, let's pick up speed now. Yes, so let's say the problem is d2y by dx square minus 2 tan x dy by dx minus a square plus 1 y is equal to e to the power of x sec x, right? So here p is equal to minus 2 tan x, q is equal to minus a square plus 1, and r is equal to e to the power of x sec x. Now to get rid of to remove dy by dx, u would be equal to e to the power of minus 1 by 2 integral of p dx. Now e to the power of minus 1 by 2, p is minus 2 tan x dx. Now minus 2, if it comes out, cancellation happens, right? So we are left with e to the power of tan x, integral of tan x dx. E to the power of, now if you remember, great. If you don't remember, you have to figure out this very quickly. So this is actually log of sec of x. Basically, you just write it as sin x cos x and apply the quotient rule. Okay, so now here e and log cancel out. and you are left with sec x. So u is equal to sec x. Now let's look at the solution. Let the solution be y is equal to u times v. The equation reduces to d2v by dx square plus iv is equal to s. So we have to figure out I. I is equal to, we know, is q minus 1 by 4 p square minus 1 by 2 dp by dx. Now q is minus a square plus 1 minus 1 by 4. P square is, P is what? Minus 2 tan x. So minus 2 tan x square minus 1 by 2 dp by dx. So dp by dx, p is 2 tan x. So this would be minus half times minus 2 sec square. So this would become minus a square. Let me write the minus properly. Minus 1 minus, because of this square, this 2 will become 4, 4, 4 will cancel out, but this minus will become plus. So this remains minus. And we end up with tan square x. Tan square x minus, again 2, 2 cancel out, minus, minus cancel out. So plus sec square x. Now let's take this minus and tan square x together. So let minus be outside. So we get 1 plus tan square x plus sec square x. 1 plus tan square x is what? Sec square x plus sec square x. These two cancel out. We are left with minus a square. So which means I is equal to minus a square. Now s is equal to r by u. Now r is what? R is e to the power of x sec x. U is what? Sec x. So these two cancel out and we are left with e to the power of x, right? So let's go back to our equation. So reduced equation. So d2v by dx square minus a square v is equal to e to the power of x. This is I and this is s. Okay. So now this can be written as d square minus a square v is equal to e to the power of x. Again, we know how to solve this. Auxiliary equation is m square minus a square is equal to 0. M square is equal to a square. That means m is equal to plus or minus a. That means complementary function would be C1 ax plus C2 minus ax. Now coming to pi, we'll write it as 1 by d square minus a square e to the power of x, and this would be equal to, if we look at our equation, here, e to the power of x, so e to the power of mx. So here m as part of that, not this m, as part of this standard equation we have 1. So we just substitute it. So this becomes 1 minus a square e to the power of x, right? So pi is this. So v would be equal to C1 ax plus C2 minus ax plus 1 by 1 minus a square e to the power of x. General solution would be y is equal to uv. So u is sec x, v is this C1 ax plus C2 minus ax plus 1 by 1 minus a square ex. So this is the solution. Now, let me just very briefly do a third problem. I'll not, I'll, do it from somewhere in the middle, right? I'll start with d2v by dx square plus 5 by x square v is equal to x square, right? So we have something like this. So what do we do? First of all, we need to get rid of this x square here. So let's multiply it by x square. So we get x square d2v by dx square plus 5v is equal to x to the power of 4, right? So now let x is equal to e to the power of z. So that means z is equal to log of x. Now if we do the substitution, this becomes x square. This can be written as d square. We know x square d square is nothing but d1 times d1 minus 1. Here d is equal to d by dx and d1 is equal to d by dz, right? This we have already seen. Now what we can do is write it like this: d1 square minus d1 plus 5v. If we look at the equation, is equal to e to the power of, what is there? E to the power of x to the power of 4 is there, right? So x to the power of 4 would be e to the power of 4z. Now this d square minus d has come from this d square minus d1 square minus d1. Again, we know how to solve this complementary function. To figure out that, we auxiliary equation, so m square minus m plus 5 equal to 0, right? And we solve that. Then we figure out the pi. So to figure out pi, we will be doing 1 by d1 square minus d1 plus 5 e to the power of 4z. That we will solve and we'll arrive at the solution. Here, just wanted to show you how in between, if you get x square in the denominator, you have to convert it into a homogeneous before you can solve it. Okay, I think that's enough for today. Bye for now.